Okay, Algebra 2. We're dealing with the last lesson in Chapter 7, 7.8. And, we're going to talk about the horizontal line test. We're also going to talk about what it means to be one-to-one. A function is one-to-one if it passes the horizontal line test. That means that a horizontal line crosses the graph, including any points, obviously, at most one time. In other words, as soon as a horizontal line would cross 2, 3, 4 times, that's no good. And by the way, these are going to be some of the shortest problems that you're ever going to have, and that's really delightful. So look, a little snapshot of what you will literally see on ALEKS. These are actual pictures. So they'll say yes or no, is this one-to-one? So here's the thing. We could go ahead and envision that we're drawing a horizontal line here. How many times would that cross? Once, right? You could draw another horizontal line. This would just cross once. Here, going through the hole, it doesn't touch at all. Holes don't count. And then you come down here, you just touch once, you just touch once. Is there ever a horizontal line where you cross 2 or more times? No. So we're going to say we're good. This would be one-to-one. Okay, as long as any horizontal line doesn't have 2 or more intersections, we're going to say that we're good. It's very much like the vertical line test, but now just flipped left to right. Okay? So as we look right here, this can be so stripped down, and sometimes kids feel a little uncomfortable, but whether it's a connected graph or you just have some disjoint points like here, this line that I cross would just touch once. This line just touches once. This line just touches once. A line down by -3 doesn't touch at all. Do I ever have a problem? Do I ever cross 2 or more times? No. So we're good. We'd say yes, we are one-to-one. How about this next one? Maybe you can see what's happening. A horizontal line would cross a whole bunch of points here. It would cross like 4, and as soon as you cross more than once, you'd say no good. That's a no. Right? If you cross 2 or more times, no good. How about this one right here, this upside down parabola? What do you think? No way. Horizontal line would cross twice. 2 or more times, you're in trouble. How about this line right here? Would we be okay? Yes. Any horizontal line would just touch once. Touching once is okay. It's when you touch 2 or more times that you're in trouble. How about this last one? What do you think, guys? Yes or no? No. Look at y = 2. This line that I just drew in. You'd hit 2 points, so that would be no. So some of the shortest problems that you're going to have this chapter, I hope that's really, really good news. So we're going to go to the back, and we're going to talk about inverse functions. Inverse functions, guys, are really like an undo button. You've got your Chromebooks, you've got your computers. You can say, hey, I want to undo what I just did. That's what an inverse really is all about. And ultimately, what you need to know is the original function compared to the inverses. You're always going to switch x and y. Now, the way we write an inverse is we put a -1 up there. We already saw that with trig. So look at function g. Function g is just a set of points. It's just 4 ordered pairs, 4 points with an x, y. I'm going to write out what G inverse is. G inverse, you just have to switch x and y. Every point gets flipped. So I no longer have -8, 7. I'm going to have what? 7, comma 8. I'll no longer have negative 3, comma 6. I'll have 6, comma negative 3. I'll no longer have 4, comma negative 7. I'll have negative 7, comma 4. And I'll no longer have 7, comma negative 5. I'll have negative 5, comma 7. We just switch x and y. But notice, guys, please pay attention that what I've just written stylistically right here is as a notation, that negative 1, I'm saying that's the inverse. That's the inverse function of g. Now, we can right now jump over to letter A, and they're saying, what do you think g prime of 7 is? That is, if your x value is 7 on g prime, what would your y value be? Well, look right here. You've got your x value of 7. Guess what your y value would have to be? 8. Remember, it's always going to be an x inside here, and that's what we're looking for in this regard. The g inverse of 7 says, what is the output? What's the y value when you plug in x equals 7? You could see it's simply an 8. Okay? As we go to finding an inverse, look at this. Here's h of x equals x minus 13 all over 5. Yes?
Shouldn't it be a negative 8? Or is it positive?
Oh, that's a negative 8. Thank you. I miscopied that. Sorry, this should be a negative 8 right here. Sorry about that. Bad eyes on my part. Thank you so much. Yeah, when we were looking at negative 8, 7, that becomes 7, comma negative 8. So our y value is negative 8. Okay? So what's going to happen with part B? Part B, we've got y is equal to x minus 13 all over 5. And guys, as we're working through this, you're going to have to switch x and y. We're going to switch x and y. Now, when you switch x and y, you're going to have x is equal to y minus 13 all over 5. So what you do now is you solve for your new y. Now, solving for your new y, I guess I just want to tell you, you could get rid of your fractions. We were doing that earlier in the year. Tell you what, how about we just multiply both sides by 5? Look at that. And then we have to solve for y, get y all by itself. What do we have to do next? We add a 13, right? So we'll get 5x plus 13 is equal to y. And guess what our y really is?
The inverse.
It's the inverse function, as Mr. Clifford said perfectly. Thank you. All right. So that's what we have, 5x plus 13. Okay. And notice how we're writing that. We're writing that with h negative 1 of x. Okay? Finally, when you see this, there's a reason why I said that your inverse function is your undo button. It cancels out whatever work h is doing. You're starting at an x value of 3. The inverse function undoes the work that h would have done. What you're going to see is you end up right where you started. That's kind of a cool thing to notice. And it's true for any number. I want to show you, if you ever had h inverse of h of, say, 10, if you ever had that, these wipe out and you just have a 10. Okay? So, undo button, that's how it works. Now, guys, as we're taking a look at, say, example 3, when we're looking at example 3, we're going to try to find our mode. And when we're finding our mode, we're going to find the number that shows up the most. You might have 2, 3, 4 modes. So I'm going to write all these numbers down. I'm going to put check marks. let's see, I've got a 0, I've got a 0, I've got a 0, I've got another 0. And I'm putting check marks so I don't miss them. I've got a 1 and a 1. I've got another 1 and another 1. So it looks like I've got 4 1s. Every time I write them down, I'm putting down a check mark. Look at your 3s. I've got 1, 2, 3, 4 3s. Oop, pardon me, we've got some 2s also, don't we? And right here, it looks like we just have 1, 2. And then with our 4s, we've got 2 4s. So what numbers show up the most? 0. There are 4 of them. 1, there are 4 of them. 3, there are 4 of them. You know, they're saying if there's more than one mode, separate them by commas. You're going to write 0, 1, 3. That's really what you got. Okay? And it's also possible that no number shows up the most. Reorder letter B. Let's take a look at that. We'll have a 1. We've got a 2. We've got a 3. We've got a 4. We don't have a 5, but we do have a 6. We've got a 7. We've got a 9, a 10, and an 11. What number shows up the most? Well, you know, there is no number that shows up the most. So what you can do, I believe Alex is just going to want you to say there's no mode. Technically, you could say that all of the numbers are the mode. They can all represent that. You'd have the whole data set. But rather than have to write out the whole data set, when you say no mode, it's way more informative. You're saying that no number shows up more frequently than any others. Okay? As we look at number 4, the range is simply the biggest number subtracted to the smallest. So let's just see if we could find, looking through this, what's the biggest number that you ever see here? 43. And kids might say, well, wait, it's showing up twice. Yeah, it does, but that's okay. It's still the biggest number. How about the smallest number that we see? 28, right? So it's 43 minus 28. And, at that point, you're going to have your range, and then you're done, okay? So that range is just 15. Finally, take out your 89, and we're going to work out a nice little data set. You could do this by hand, but I'm going to show you how you can do this really just on the calculator. Okay, with the 89, we're going to press stat. If you want to enter in data, you'll hit stat, then you hit edit. Some of you might already see some numbers here, and that's okay. If there are numbers there, you can always go all the way to the top, highlight list 1, press clear, and then bring it down. But what I'm going to do is type in these 6 numbers. I'll type in a 5, enter, 20, enter, 18, enter, 5, enter. This is the longest part of the whole problem, believe it or not. Just getting everything typed in. Wonderfully, you can look and make sure that you didn't have a typo. You can double check that you typed it in correctly. But now what? Well, you can go back to stat, but this time we're going to press calculate. So I press stat right by that down arrow, but now I'm going to right arrow. I'm going to say 1 variable statistics, and it should say list 1. And all we have to do is just hit enter 3 times real quickly, and then we're going to get our information. Okay, X bar is your mean. X bar is saying add up all the numbers and divide by how many you have. If you down arrow, your median is given to you right here. That's 13.5.